Okay, so you're going to talk to us about the electrical problems that are related to all this water damage here?
Yes.
What's your name and what's your story?
My name is Ken Staconnor, a licensed electrical contractor in the state of California since 2006.
And you specialize in audio visual and stuff like that?
I also specialize in audiovisual, do a lot of big churches, venues, concert halls, things like that.
Okay.
Recording studios.
Would it be fair to say that you don't know everything about electrical?
Yeah,
But if you don't know something, you're going to look it up?
certainly.
And you're starting to do a lot more insurance work, so you're looking up codes and things a lot more?
Yep.
Okay, so you want to talk about some of the problems that you discovered here in this property?
Well, we're going to start with, if you take a shot of those up there, I separated those, and the reason I separated those,
You're talking about the flex
and I'm
conduit?
talking about those flex conduits right
Okay.
there. There are several of them.
Okay, and then this product here, this black thing, is made by a company called Caddy, C-A-D-D-Y?
Several companies make them, but the bottom line is that's the proper sort of clip that would go on an earthquake wire or a ceiling wire to support conduit. That's legal.
Okay, and how was it when you found it?
All just laying on all this was bunched together, just laying on top of the ceiling.
On top of the acoustic tile?
Yep,
Okay, and then that's a code violation, right?
it's a code violation
In the state of California?
for two reasons. It's not supposed to be sitting on the tile, and secondly, it's supposed to be supported 12 inches from the box and every 4 feet of the length.
Okay, but then you're also thinking that they might have used more flex conduit than they were supposed to?
I think so, possibly.
But you're going to double check the code on that?
I'm gonna double check on that. I may not have to replace the conduit, but I may have to. I just have to see what the current code is on that.
Okay, and then let's look at this one over here. You were telling me that they got this junction box that has how many flex conduit coming out of it?
Yeah, there are 7 flex conduits coming out of there, which means there are 28 wires in there. Those are number 12 gauge wires. A number 12 gauge wire in a box must be allotted 1.75 cubic inches per wire. That is definitely not a box that has a volume of 1.75 times 28, which is how many wires are in that box.
Okay, so you have to calculate how big of a box you're going to need. Do they even make a junction box that big?
Yeah, I mean, it's probably going to end up being like a 12 by 12 or an 18 by 18 big box up there. There are all new codes too about if you have to connect them. There has to be an allotment for the connector too now.
What do you mean? Oh, so you have to add a little cubic inches for the connector itself?
Yeah. So if it's just a pass-through box or a pull box where there's no wire nuts in there, it's calculated per wire rather than per wire end.
Okay, so explain to the uninitiated what a pass-through or pull-through box is.
Sometimes we'll put boxes in a conduit run so that we can have sections that we pull. Instead of, say, for example, trying to pull 400 feet, we'll maybe put a box every 100 feet to make the pull a little bit easier and a little bit less hazardous.
Okay, and when you pull the wires, you have to use that clear lube stuff?
Sometimes, yeah, it depends.
Okay.
I tend to use it all the time because it's just good practice and it makes life a lot easier on everybody. And so in the case that we just have pull boxes where we're separating the pull for the sake of the labor and for the ease of use and the less strain on the wire and so on and so forth, those boxes usually will just have a few, let's say there's a box that's 6 by 6 by 6 inches deep. We'll just have, let's say, 10 wires just pass through there and that's all they're doing.
Okay.
However, if those wires stopped from each conduit and we have to tie them together with wire nuts, we have to count every end rather than every wire that goes through.
Okay. So talk to me about this. What's going on with this fluorescent fixture?
Well, we have broken. So the fluorescent tubes go into those connectors. We, as electricians, call those tombstones.
Okay, so I'm going to zoom in on one of those.
You can see that.
So that's called a tombstone.
Yeah, you can see that they're broken, which means that they were way too rigid, which tells me something about heat damage or something. I'm not sure what would have caused that. Possibly water coming into the fixture. And
Okay, but here
heating the
you were
wires.
pointing out the black scorching.
Yeah, there's black scorching. I don't know why that's there. It's funny where it is, but it looks like what it looks like. Okay, this is another issue with this property. These systems are not properly grounded, and you have to have an equipment ground, which means a green wire is going to connect literally to the chassis, to the box of this fixture and ground it.
Okay, so you have a little
So that if
screw
there's a
on the sheet
fault-
metal with the green wire,
Right.
and then that way, if there's a fault, the current flows to the grounding, the copper grounding around outside the building instead
And
of
back
going
to the source.
instead of going
Creates-
through the human being.
Instead of going through the human or going through the fixture and scorching it.
And this fixture is not grounded according to current California electrical code.
Hardly any of them are in here. Yeah.
Do you believe that same grounding code and these other codes we're talking about, is that applicable in other states too?
That's NEC, National Electrical Code.
So
that's the minimum
Okay. All right. And
for
then
the country.
Okay. And then you were actually going to rebuild this fixture.
I was thinking about it until I looked at it and I saw, like, you know what? There's something else going on here, and I don't know what it is. I can't put my finger on it.
And you got to be safe rather than sorry.
I would rather be safe than sorry. And
Okay.
I'm looking at, like, they have a new...
Isn't that kind of old school to rebuild a fixture? I mean, wouldn't most people just buy a new one at Home Depot and stick it in there?
Well, if you look at the pattern on there, there were once 4 tombstones in there instead of just 2, which tells me that this was an old T12 fixture, and somebody upgraded these fixtures with a new transformer, also called a ballast,
Okay.
to be a 2-lamp T8 fixture.
Why would they do that?
Energy efficiency.
Okay.
Yeah.
And what is the difference between, what does T8 mean?
So a T12 bulb
Uh-huh.
is a big bulb that's about 1.5 inches in diameter-ish. A T8 is a smaller bulb, and they're small, but they're higher efficiency and they put out more light.
Okay. And then we can see on the label who made this fixture originally. So see, you were thinking about rebuilding it, and somebody else actually already did, in
Yeah.
a sense.
Yeah.
So that's interesting. I didn't realize that there was like a whole cottage industry of rebuilding
I
old
think-
fluorescent fixtures.
I don't think that's the fixture manufacturer. I think that's the installer.
Oh, really? We have to look at that closely. Okay, and then you were telling me about this conduit here. So this gray conduit, you believe is how old?
Oh, over 30 years old.
Because why do you believe that?
It's made of steel, and it's how they used to do building grounding. Instead of running a grounding conductor, they would just run flexible steel conduit to everything and not put a ground in the boxes.
Okay, but the conduit is grounded at some point.
At some point, it's ground, yeah, but it's no longer suitable to use flex as a ground.
Okay.
Any kind of flex.
And then you're telling me like all these shiny ones are aluminum.
Yeah, and they can't be more than 10 or 12 or 15 years old, maybe
Okay,
20.
but
20
you
at
can,
the max.
aluminum also conducts electricity. Why can't you ground the aluminum conduit sheathing?
Not to code.
Okay. It has to have a separate dedicated
conductor.
ground wire inside of it.
Yeah, the term is grounding. Ground dead is neutral. Grounding is green ground that grounds to the chassis of everything.
Okay, so say that again.
So a grounding conductor is equipment ground. It grounds to the chassis of everything, like it would ground to the chassis, the box of this light fixture.
So a grounding conductor is the green wire that is attached with a sheet metal screw to the outside of the fluorescent fixture.
Or to the inside, yeah, to the
Okay,
fluorescent fixture.
and then
This-
grounded means what?
Grounded is neutral. That's the direct path back to the source for the electricity.
Is
We
it-
don't want to get too much into theory.
Is it neutral the white wire?
Neutral is the white wire. It's called a ground dead conductor.
So the white wire is also a ground?
It is. Yeah.
Why do you need both?
In case there's a short to ground. And let's say, imagine that the hot wire somehow comes loose and one of its little strands touches the box of that fixture, the actual chassis of that
Okay,
fixture.
then the green grounding wire would save you,
The
right?
grounding wire would take over. The grounding wire and the neutral wires are all connected at the panel, which still provides a path back to source, thereby allowing the breaker to trip. If that green grounding wire wasn't there, the breaker wouldn't trip, and we have overheated wires.
and then the
short
white
circuits
wire is
galore.
for what?
Grounded. It's
No,
the
why do you
main
have the
ground.
white wire in addition to the green wire?
Because the white wire is the way the electricity works is you have a source, and it goes through the fixture, through the wires, through the fixture, and then back to the source. That's what the ground dead conductor is for, the white wire, the neutral.
Okay.
A
So the white
grounding
wire is like
conductor-
the main grounding, but the green wire is just like the accessory grounding.
The green wire is in case there's a fault to the equipment.
Okay.
The electricity still eventually gets back to the neutral so that the breaker can detect it and break the circuit before somebody dies.
Okay, now, on this property, based on what you know, it is grounded like through the old 30-year-old darker conduit, right?
Yeah.
So you would assume it has got to have a grounding rod at the panel, correct?
I don't know how they grounded this building at that time. There's probably a U for ground,
A what?
which is basically a number 3 rebar built into the structure of the building and ending up in the ground, and you ground to those.
So can you see that piece of rebar?
I'm not sure that there's one here. I'm not sure what they
But
do.
if you have one, you would see it? It's on the outside?
There's usually a plaster ring or a drywall ring with a cover over it that you can take off and access the connection.
So it's inside the wall.
Yeah.
So the building could be grounded with a steel rod instead of a
Yes.
copper?
Right.
And it's inside the wall, and you wouldn't know where it was unless you knew to look for it?
I would have to, yeah, I would have to.
Okay, so my house has a copper grounding rod.
That's because you had a panel upgrade and somebody was smart enough to know to do that.
Well, it's required by
It
code.
is required by code. Now,
And-
now a second one is required by code.
Okay, I was going to ask you that because sometimes I've heard people say, like, oh, my soil is not good for grounding, and they made me put 2 copper rods.
Doesn't have anything to do with soil. It's just code now.
In
You have to have-
California?
Yeah. You have to
National
have-
Electrical Code?
National Electrical Code says that you have to have 2 copper grounding rods tied together with a contiguous wire 6 feet or more apart. And
Okay.
the more is determined by the city requirements.
And you believe this is on all houses in America?
All homes. It's an NEC thing.
Okay, now, so what that means is if you have an old panel, and we talked about this before, where your panel has to get upgraded due to water damage to wiring, you're saying that you probably have to put in 2 grounding rods if you only have 1?
Yes.
Okay.
Yes. In the case of a single home, in the case of a single dwelling residence, yes.
Okay, so let's talk a little bit more. You're saying like the wires, somebody had put wires that were underneath the ducting and it has to go above the ducting?
Well, yeah, because you can't. I'm not 100% sure on this code. I don't know if there's a minimum distance above
So
above the T-bar ceiling, but I think there is. At the very least, though, do you see how that one right there has a gray clip instead of a black clip like those other ones, but they're the same
okay,
thing.
you're talking about this gray clip right here.
Yeah, with the big steel flex.
Okay.
We put that on there so that it would be supported.
Okay.
Flex conduit has to be supported within 12 inches of a box and every 4 feet.
Okay, now I notice your conduit here with your little gizmo. What did you call that black thing?
It's called a caddy clip,
Okay.
and the size of that caddy clip is K12 for half-inch flex conduit or 3/4 inch
Okay.
EMT conduit.
So you're basically clipping the conduit onto the wire that's already there to hold the T-bar ceiling.
Yeah,
And that's kosher?
yeah.
Okay.
But we've also, in order to adhere to the code, we also just install our own wires just to let them hang from.
Okay, so let's talk about, this insurance claim with water damage. We had water all over the place. I don't know exactly how much water, but you had all the ceiling tile went damaged. And
Well, you can see how much drywall was replaced. There's a lot of
oh, this is all, so that's old drywall with the brown, and this is all new drywall here?
Yep, that's what the mitigation contractor did.
Okay, so how do you know water didn't get inside the conduit?
I don't. It's flex conduit, so did it get in the conduit? I'm sure.
You probably
Why
did,
wouldn't it?
right?
It's not water.
And have you been testing the continuity and everything here to find shorts from water and stuff?
No.
Has the property owner or the tenant reported any kind of electrical problems?
No.
Okay, but you do have at least some damage, like this scorching here.
Yeah.
You have some damage that's clearly direct physical water damage from all the water.
Yep.
And then you have probably a lot of other damage that may not really be readily ascertained.
I mean, yeah. I mean, any water that fell in there, like it was a purified water line. So purified water got sprayed up into the ceiling.
Oh, how
But then it all-
interesting. Because
but then-
purified water doesn't really cause damage the way...
No, it doesn't. But it did. But it did hit the drywall, and there was all kinds of dust and junk up there, and it picked up material on the way down. to
Why
give you
was
the
it a
pictures of
purified water line?
Because they have a conference room over there,
Uh-huh.
and they ran a line. They plumbed a line, a plastic line, from their water source to their water cooler, so that they
Okay.
can have a regular and consistent source of water.
Drinking water, yeah.
And rats chewed it. You can see.
So
different
rats
places.
are the efficient proximate cause of this loss.
Absolutely. You
Or
can
the water
see-
leak is.
You can see in places. I don't remember where they are. There's a couple of spots up here where the exterminator tied some rat poison up so that the rats could get it and die.
Okay, but see, then they die inside the wall and they're really stinky. So
Well, they all died in the ceiling. So
is there any additional electrical issues you want to point out to your fan base? Because now you have a fan base, like Kardashian.
well, I don't know where this is going to go, but it's an old panel. I'm a little concerned about how it's all going to be grounded back at the panel. I haven't investigated that yet. I'm not real familiar with 30-year-old, 40-year-old wiring and how they used to do that. I mean, certainly the way they grounded the steel flex to everything else is
not to
is
code.
the old way, but way over 30 years old.
Okay.
Oh, look, Susan
Okay.
brought us the
Rat
plastic line that was chewed by rats.
Okay. And I see this really small line. Okay, great.
And that's where all the water damage came from.
Okay, well, thank you very much. I'm going to end the interview now. And appreciate all your education. And then maybe you can look up some of the codes and then send them to me, and
I always will. Yeah.
and I'll post the codes that you learn and additional information, or you can answer questions, so we can all learn. Thank you very much.
For sure.